Welcome back. This is Electronics Trivia, and I'm your host, Steve Wagner. What you see in front of you, or on the screen, is what we would call a conventional bench power supply. What makes it suitable for the bench is these front panel connections. This particular one is a Hewlett-Packard, 0 to 20 volts, 0 to 3 amps. Now, because it's intended to be used under multiple circumstances, the meter is capable of being switched to 24 volts full scale, which is where it's at now, and it has a coarse and fine adjustment for voltage and current, and it can be switched to like 2.4 volts full scale. So right now it's set at 1.2 volts and the fine adjustment. Classic bench power supply. This is another bench power supply made by Lambda. Lambda was very well known as a power supply manufacturer. Again, we have the classic front panel terminals. We have a coarse and fine voltage adjustment. You can barely see the needle move. This one I assume is rated for perhaps 30 volts full scale, although it's capable of 40. It has a 3 amp full scale meter. It is current limiting, but it's not got a fine adjustment for the current. This is a liter, again, bench supply. It has adjustable current limiting, and it has adjustable voltage. Again, the characteristic front terminals. This is a Harrison. I think Harrison was exclusively a power supply manufacturer, and they were a subsidiary of Hewlett-Packard. We have the classic front terminals. We have a coarse and fine voltage adjustment and a coarse and fine current adjustment, and the meter is switchable between volts and amps. We only have a single front panel meter. This supply, although it's quite large, is only rated a full output current of a half an amp, or 500 milliamps. What I have here is another Hewlett-Packard power supply. This power supply is rated 0 to 40 volts at 0 to 30 amps. It was never intended to be a bench power supply. It was to spend its entire life sitting in a 19-inch rack powering something, either in the rack, adjacent to the rack, or maybe hundreds of feet away. It has no front terminal connections of any kind. It does have a coarse, a 10-turn coarse, and a 1-turn fine voltage adjustment, and a 10-turn coarse and a 1-turn fine current limit adjustment. It also has an overvoltage adjust, which shuts the power supply down in the event I adjust it to more than whatever this overvoltage adjustment is set at. Now, it's recessed and it's screwdriver adjustable. It has a 2-pole circuit breaker that's intended as the on-off switch, has a power indicator. It has a voltage and current meter, The voltmeter is 0 to 50 volts full scale, intended to work 0 to 40 volts. And the current meter is 0 to 35 amps full scale, intended to work at no more than 30 amps. So that's it. It's a very plain power supply. I bought it from a junk dealer 20 or 25 years ago, and I've never powered it up. Give you an idea of just how big this is. The chassis appears to be about 17 by 17. These filter capacitors are about 5 3/4 by 3 1/4, and they're 40,000 microfarads apiece. There's a power transformer in here. That is 6 by 7 1/2. A cooling heat sink and fan assembly, the regulator component itself, some meters. This weighs almost 80 pounds. I know I can't move it myself. You can't see it, but this entire depth is 7 inches. Now this is the rear of the power supply. Sorry about the lighting situation. You can see an acceptance sticker dated June 24th, 1980. The power connection, 230 volt, single phase. So there are 3 terminals and a ground over here. L1, L2, and a neutral. Although I don't think it's a neutral, I think it's actually a ground. These bus bars are intended to be where the power's taken off. The bus bar is about 5 inches by 1 inch, and it appears to be about a little less than 1/4 of an inch thick. Somebody has decided to connect the negative side to ground, earth ground. One feature that all of the higher quality bench and rack mounted supplies have is provisions for external or remote mounting of the controls, voltage and current limiting, and provisions for local or remote monitoring of the voltage. This probably indicates local monitoring, but I need to take off this protective barrier to ascertain the exact facts. If this powered a load device that was electrically distant from the power supply. Now by electrically distant, I mean that there was some voltage drop, or there could be some voltage drop between the power supply and the load. Electrically distant is a factor of the current, which could be up to 30 amps in the case of this power supply, and the size of the conductors, and of course temperature variation. This could have powered something 150, 200 feet away. It could have powered something in the center of a parabolic dish mounted on the roof of the building. And so that in order to avoid the variations in voltage drop between the power supply and the load, there were always provisions made to run 4 wires to the load. That is, 2 wires of some physical size to carry the current, and 2 wires of some insignificant size, because these will only carry a couple of milliamps at most. These are hooked to the voltage measuring and regulating circuit. So by measuring the voltage 150, 25, 200 feet away, we're actually getting the voltage at the load. And we can regulate the voltage at the load that way. The actual size of these voltage sensing conductors could be very small. It was usually picked based on just physical strength. After all, if it was installed in a conduit or subject to weather conditions, it needed to resist some strains. At least, if not during operation, at least during installation. All of the bench supplies, except I believe for the leader I showed earlier in the video, have the same provisions for remote monitoring, and in some cases they have provisions for remote adjustment, where the power supply just sat in a rack most of its life, or all of its life, powering whatever device was selected. In order to provide a set of terminals for the power supply, I took this piece of 19-inch rack panel space filler, and I drilled and mounted a green ground terminal, 2 dual red and black binding posts, and 2 individual red and black binding posts. I intend to wire the power supply output bus to these 2, and they'll be connected in parallel. I intend to wire the V-Sense to this set of terminals. And then I put a ground terminal in the middle that I can use or not use. And I made a note that you better connect the V-Sense to the power supply output, or remotely in the event that I want to do some remote sensing. And because I might mount a second power supply, I went ahead and did the other end of it. Well, here's the power supply mounted in a rack. For those of you who watched my new work area videos, this rack is on the right hand end of my new work area. As I mentioned earlier in this video, the power supply is so heavy I can't move it around. And I had the gun shop open over the weekend, and a couple of guys that looked like they could bench press a Volkswagen came in. And so I had to slide it in the rack. I was unable to power it up until they put it in the rack. I wasn't going to pass up the opportunity to have the heavy lifting done by somebody else. Once it was installed in the rack, I went ahead and ran 220 volt single phase to it, powered it up. The meters worked as they should. And then a bunch of white smoke came out of the power supply. I turned it off, removed the top cover, exposing the portion of the supply seen earlier in the video, powered it back up, no more white smoke. I've run it for about 5 hours. There's a little residual smell, and it doesn't smell like anything it smells like wood smoke. I'm hoping it's a spider that put a little nest inside. Whatever it is, it's on the switched side of the power. And then I mounted above the power supply a set of terminals. These terminals, with the exception of the green one, are not hooked up. I did hook the green terminal, which is an earth ground. I don't like to have green terminals sitting around unhooked up. It's like a fire hydrant not hooked to a water line. These terminals are live, and I've got a jumper between these sets on both the positive and negative side. Power supply is adjusted to about 5 volts, and I'm going to connect my dummy load. The dummy load is drawing a total of 6.15 amps, which is pretty close to what the meter indicates. Voltage is measured by the dummy load is 5 volts. If I turn the current limiting down, you'll see the voltage fold back. Well, it just did. So the current limiting does work. Of course, it doesn't go above 5 because that's all the load I have. Now I have about 12 volts at 6 amps. Again, we'll limit the current. And you see what happens when I hit the limit. It just folds back. I haven't adjusted the voltage, the over voltage. I know it's not set for 40 volts because I can take the power supply up to somewhere above 40 volts. So there we have a 40 volt, 30 amp, well-regulated power supply. I looked at the AC ripple here using the voltmeter, and it's about 0.005006. There's no more smoke, just a little bit of smell that may be residual. So if you've liked this, if you're interested in this kind of stuff, drop me a line, subscribe, or come back to my next video. Thank you.